So we are in day 5 of Advent of Code. Even though we're 15th, we're trying to catch up. So I already went ahead and solved it off camera. It was actually pretty annoying. I'll explain why. Essentially, the problem is pretty simple. You're giving crates, and you want to move them from one to the other. So if you look at the example, you move 1 from 2 to 1. So you move 1 from 2 to 1. And then that gives you this. And then move 3 from 1 to 3. So if you move move 3 from 1 to 3. So if you move 1, if you move 3 from index 1 to 3. If you notice the order it's kind of like, is it a stack? Where you pop them from the top, so that becomes the bottom. That's why they're ordered like this. So when I saw the problem, I thought it was pretty simple. But the annoying part was reading the file. So it took me a while to finally understand how to read the file, just because it's very annoying. So you're reading it line by line. So first off, I split it from this side, the commands, to like the grid. But then you're reading it line from line. So then I read it in the reverse order. But then when you read it from the reverse order, you're given the arrays ZMP, NC blank, blank, and so forth. So let me show you guys how it looks. This is already done. I already solved them. I'm just explaining the code now. So it puts building blocks and then you return here. Let's see if I run it. Let's pretty burn it. So as you can see, it's read as ZMP, NC, and then nil, and then D. So there's a method in Ruby called transpose, which will match the first index or will match the indexes at every subarray, and then group them together. So the subarray 0 indexes would be grouped together. So it would be ZN and then nil, which is what we want. But that only works if the subarrays are all the same size. So as you can see, this one is 2, and sometimes it's 1, sometimes it's empty. Well, it's only when I'm reading it. So I add nils to I add an extra like item in the subarrays to make them all the same size, and then I transpose them. So if I show you the transposing, let's see. It was so annoying, man. It took me so long to understand how to read it correctly. It took me longer than to actually code out the algorithm of how to solve this. So annoying. So this is the how we're reading it, and then after we transpose it, it's created the correct way. So then after you get the correct grid, I'm splitting the commands. So I'm splitting it using from. So subarrays move 1, and then the other one is 2 to 1. And then for each line, I get the location. So this is splitting the second part. So it's from 2 to 1. So I get the amount, however many times we're going to repeat it. The from, the to. I did a for loop for this, and then you pop them. Array to pop, and then you just add it to the new array. And I think, yeah, so this part right here was like the easiest thing. I struggled a lot with this initially. I'm like, how the hell do I read it? But after I read it, everything else was pretty much easier from there. So if I run this, let's see. It shows you each step that it took, and then the challenge one at the top, the letters from the top of each stack. So in this example, CMZ is the answer. And for the sample, we get CMZ. And now if I change it to the actual input, and I rerun this, so you can see however many steps it took to run this. And then it gives you the top of the stack. So this is the input, the moves for each. And then, yeah, I inputted it and I got the right answer. And then for step 2, the only difference was you're still popping if it's just one item, but if it's more than one, if you're moving 2 or 3 items from the stack, instead of popping, you're just carrying them over in the same order. So for example, you move all 3 from 1 to 3. Instead of being the reverse order like in part 1 here, they are the same order in which they're being moved initially from. So in the code, all I did was so I'm popping if it's just one, and then if it's more than one, I pop the amount, and then I just concatenate that array. I initially thought I had to reverse the array, but as I'm popping them, I'm already carrying that order, the correct order, so I didn't need to pop them. If I run the sample, end of input. All right, what's wrong here? 112. Oh, extra S. Okay. So here you can see ZND, MCP. The items that were popped were ZND because you're moving 3 to 1. But they're already in the correct order, so I just concatenated them. So if you see here, PZND, and you compare it to the example, you see here. Let me see, ZND. Where are we? You pop, yeah, right here. ZND. You pop all 3 of them, and then you add it to the 3rd index, and they're added in the right order. So yeah, and then if you run the whole input, I already ran this, but just because I like seeing the logs. Yeah, we get the right letters. So yeah, that is day 5. Yeah, so the most annoying part of this was just reading the text file. It was so annoying. It was so annoying. Hopefully it gets easier. I'm scared it might not. Just because it's like I initially knew, all right, once I read it, I'm like, okay, so we're working with stacks. We're working with array.pop. And we're working with indexes and repetitions. And I'm like, okay, I already have an idea of how to solve it. But I just struggled with reading it. And again, this code is very inefficient. And I'm learning Ruby, so I wouldn't say this is the greatest Ruby code y'all would ever see. It's probably the ugliest thing y'all would ever see. But yeah, we're just solving the challenges. What did I learn? Transpose. They have to be the same size. So interesting. Yeah, that's it. Moving on to day 6.